Alright, just before we get started with this video, just remember you can always kind of fast forward through these and go back and replay them. I think there's even ways you can slow it down. But just go through these problems as many times as you need in order to get the understanding of these, alright? And I really hope it helps you with the test. And good luck with that, alright? So I'm just going to do this in order. So if there's a problem specifically that you want to go over, then just fast forward it to that point and go over that problem as many times as you need. But again, it is highly suggested that you do the practice test by yourself. Treat it as though it were a test. You have to do that in a lab or in the library or at home. It doesn't matter where you're at. Treat it as though it were a test and actually practice it so that when we do the test, hopefully you're prepared for that, alright? Well, let's take a look at number 1 then. Alright, so in this test, it's also possible that you'll be able to use, or you will be able to use rather, a calculator on all these problems. So even if you don't know what the 6th root of 729 is, it's not a big deal, because you could put that in your calculator. Now, just simplifying this though, we'll use the rules of roots or radicals, whatever you want to call them, to split this up. So we're going to take the 6th root, let me make that a little bit bigger for you, 6th root of 729, and this is multiplied by the 6th root of x to the 36th. This may be a little bit easier for you to see. In any case, the 6th root of 729, and you could make a factor tree with this, whatever you want to do. As it turns out, the 6th root of 729, well, 729 actually is 3 to the power of 6, which means that the answer to that part is just 3. Now, working over here with this 6th root of x to the 36th power, some of you may look at this as though it were an exponent. Now, yes, I'm kind of doing this in different ways, and that's just to help you see that there are different ways to look at these roots. And I don't care which way you do it, as long as you get it down and have an understanding of how to do it, that's fine with me. So we have a base of x rather, and the exponent is 36 sixths. 36 divided by 6 is just 6, and this is our final answer for this problem. Alright, number 2, find the cube root. Well, I suppose it's not the cube root, so I'm not going to worry about that. It's just a typo. So we could just say, to simplify this, kind of like the last one, and since that's a negative 1024, we know the answer is just going to be a negative. And that is possible because the index of the radical there is 5. It's just the 5th root. Since that's odd, we can pull out that negative. And again, I'm going to go ahead and split this up. We've got the 5th root of 1024 times the 5th root of x to the 30th. Alright. And just doing these individually, it's going to stay negative. The 5th root of 10 to the 24th, well, 1024 is 4 to the power of 5. And this is 5, the 5th root rather, which I will write as an exponent again. So we have x to the power of 30/5. And just simplifying this, we've got a negative 4 times 30 divided by 5 is 6. So that is the exponent of x, and this is our final answer right here, negative 4 x to the power of 6. Alright, on this one we're going to find the domain and then graph this function. On the test you have the function, and this is the practice test, so it's not a big deal. I can graph it by hand though, and hopefully you can see how that works. So the first thing we're going to want to do is create a table kind of like it did on the homework for us. But in this case, we're going to have to find our own values of this. And we'll have x and the f of x values. And we just need to choose some values that will work for this, alright? And hopefully we'll see a pattern emerge from this. Now we know in this function that we can't make the radicand, which in this case is x plus 5, we can't make it a negative. What that means is that the lowest value of x that we can use is a negative 5. What that would do is give us a 0. If it went any lower than that, then it would give us a complex solution, which we can't graph right now, okay? So we can't really worry about that. We don't have to. But let's look at some other values that will work for f of x. So we're going to choose these values of x very strategically because what we want is for the answer of x plus 5, we want these to be perfect squares, alright? So to do that, what we need is perhaps even a list of perfect squares that will work, such as 1, and then 2, and then 3. So these wouldn't be the perfect squares. These are the square roots of those perfect squares, the square of which is 1, 4, and 9. So in other words, something plus 5 needs to equal 1. And you could solve this like you would any other answer, not answer, but an equation. And we know that negative 4 plus 5 would give us a positive 1, the square root of which is 1. Now, if we wanted this to equal 4, we'd subtract 5 from both sides and find that x, there is a negative 1. If we wanted this to be 9, then x would be 4. So if x plus 5 is 9, then the x value there is 4. And let's look at one more value to see if that kind of helps us out here. If we wanted this to be 4, well, 4 squared is 16. So something plus 5 needs to equal 16. That's 11. And that's kind of far to the right on a graph. That's alright, as long as we're making the graph. But I'm going to give you guys graphs to use on the test. So just making our own, which isn't a big deal. Let's go ahead and make this line a little bit more straight. So I'll use the line here. And then I will use a line here. Okay, and then I'll just give ourselves some tally marks. Actually, let's go ahead and move this line up because our first value, where x is negative 5, that's our x-intercept because y is 0. So x is negative 5 back here. 1, 2, 3, 4, 5. Yeah, this isn't going to be so accurate because of this being drawn by hand. But that's okay. Alright. Now we know at negative 4, the y value is a 1, which would be right about here. At x is negative 1, y is a positive 2. And then finally, when x is 4, 1, 2, 3, 4, the y value is a 3, so it would be up here. Now this is curving as we go, so we'd want to show some type of curve there. I've hit all those points all right. And so the graph would look perhaps something like this, okay? All right. So that's the graph about what it would look like. You can do that on an actual graph, and hopefully that would help you out. So since this is the graph, the last thing we actually need with this is the domain. And the domain in this case, we want to write the domain in interval form. And you'll have to do this on the test. The lowest x value we can have is this -5 that we put in the table. And then since that arrow goes all the way to the right, it'll go there forever. It will go to infinity, and that's the domain. Alright, we'll do this one as well. Now since this is a cube root, right away without any calculating, we know that the domain will go infinitely to the left and also infinitely to the right. That's because we can have negative values there. We can have negative values now inside of the radical or the root. So it will go all the way to the left and right. And if you didn't know that, that's fine. We're going to go ahead and graph this thing, but first let's go ahead and do the same thing we did on the last one, number 3. Let's go ahead and make a table for this, alright? And we'll do the same thing. We just want to find perfect cubes. And we only need a few of them before this one really gets out of hand, alright? You'll see what I mean here in a second. And then we've got this f of x. That's our y values. So we'll choose x values very specifically. Let's go ahead and look at some cubes, perfect cubes, such as maybe 27, alright? Well, actually, that one's going to be a little bit big. So if we said, if we wanted x plus 3 to be 27, x is going to be rather large. So we're going to skip the 27 thing, which is alright. Another way to look at that is maybe you want to start with 0, and that's fine, but remember it's going to go in both directions. So I would want the 0 value to be placed here. 0 cubed is the same thing as a cube root of 0. That one should be pretty easy to find because all we need from that is x plus 3 to equal 0. And since that's the case, we know x would be a -3. That may just be helpful for you to start this out. I don't know. In any case, I do hope it's helpful, though. Plus, where the y is 0 is going to be pretty easy to put on the graph. The next thing we'll want, perhaps, so I'm going to go in the more into the negative direction, up into the table, and down I will have higher or more positive numbers, alright? So, for example, the next cube would be, perfect cube is 1, and then the next perfect cube is 8. So, these would be negatives though. So if I wanted x plus 3 to be -1, which is good, then I would subtract 3 from both sides, and I would find that I would need the x to be -4. Sorry about that. And when x is -4, the cube root of -1 is a -1. Likewise, we can look at these numbers here. The cube root of -8 is a -2. We'll know that before we even start this process of solving for x. So in this case, we want the y to be a -2. I apologize. We want that to be the cube part of that, so we want it to be -8. So subtracting 3 from both sides, that would give us a -11. Okay, and that'll be, we can graph that, it's not a problem, but just so you know, that'll be pretty far to the left. I don't know if the graphs I have on the test are big enough to handle that type of value. That's okay. Well, going in the other direction, we've got a 1 and then an 8. So if I wanted the cube root of x plus 3, so if I wanted x plus 3 to equal 1, that would be a 1 as well. Now it's positive. So subtracting 3 from both sides, I've got this negative 2. But if what I want is for it to equal 8, now I'll subtract 3 from both sides and get a negative 5. Cubed root of 8 is 2. So now we have a substantial amount of coordinate pairs in order to graph this. And it should look pretty good. It'll be pretty thin here, so let me put that more towards the middle here, like this. I don't know if that's straight or not, but I hope it's straight enough for you. And then like this. Then we're just graphing those points. I can't put this negative 11, negative 2 on the graph, but I know I can put negative 4, negative 1 on the graph, which would be right here. Negative 3, 0 is right here. Negative 2, 1 right here. And I apologize, that is not a negative 5. I apologize. Very tired at this point in the day, and I made a small mistake there, and that's okay, we've caught it. But yes, that x value is actually going to be a positive 5. 1, 2, 3, 4, 5. And then f of x will be a positive 2. So that puts me right about right here, okay? So negative 2, negative 11 would be way over here. This is going to curve a little bit. So let's go ahead and see what this graph would look like. Moving from this direction, it should come up and then into this point, slightly increasing to the right and to the left, okay? Decreasing to the left, though. So we have our domain and graph for this. I hope that's helpful. I know it's rather long, but at the same time, I understand that some of you may be skipping some of these parts, and that's all right. Alright, use radical notation to write this expression. So we can't use exponents in this unless it's inside a radical. Looking at this also, let's go and take a closer look at the expression, knowing that we need to write it in radical notation. Alright, well, since we've got this is a power of 1/3, that means we can use the radical. We can take this xy squared, and some of you may not use these parentheses, just I'm doing it just to illustrate the concept here. The numerator value here is 1. The denominator is 3. Let me put that in a color here just so you know where that goes. And the 1 is right here, okay? So we've split up that fraction in this radical this way. Now the 5 is still in front. Please do not forget that 5. Otherwise you're going to lose points on the test. Now that we have it to this point, it's to the power of 1, so that's not really going to make a difference. Let's go ahead and look at these separately. Well, there's not enough x's to pull out of this cube root, nor y's, but there is enough z's. And if I look at this separately, we've got the square root of x, y squared, z cubed, z squared. What this allows me to do is break this up. I have, well, that's a cube root of a z cubed, which allows me to pull that out. I would then have 5z, and then the cube root, this one went out, so we've got xy squared, z squared. And that would be your final answer. So yeah, I know it didn't really say to simplify on this, but it is important that you always do when you can. That was just a small illustration of that, and it should be something you are capable of doing at this point in the chapter. Alright, these instructions for 6 are also the same instructions for 7. So we're just going to simplify these expressions, but we'll only be using positive exponents. So So keep that in mind as you solve these, alright? The first thing we're going to do on 6, let's go ahead and look closer at that. So this is number 6. What we have here is, the first thing I'm going to do is use the exponent property to distribute that 1/3. What that's going to do is going to give me a y to the 20/3. That's the numerator. But distributing this 1/3 in here gives me y to the negative 7/3. And that's important because what we're going to do is, since we have a negative exponent, we want it to be positive. And since there's this negative in the exponent, it means we're going to reciprocate just that term. What that means is it's going to flip that part, just that part. We still have y to the 20/3, which was positive. There's no need to reciprocate y to the 20/3. But this is now multiplied by y to the positive 7/3, because that was already a positive exponent. And since we have the same bases, we can add the exponents 20/3 plus 7/3, which would end up giving us y to the 27/3. But that can be simplified as well. 27 divided by 3 gives us our final answer, y to the power of 9. So if you find that that exponent can be divided, which in this case it can, go ahead and divide those and simplify that, alright? You can put that in your calculator. It's not a big deal. 27 divided by 3, that would have given us this y to the power of 9 as well. So always be aware, thinking if there is a different way or another way that we can simplify this, which in this case there was. Also, don't forget about this, because I remember seeing this on the homework. Some of you will reciprocate this y to the negative 7th right away, and then it causes a weird technique when we're combining these exponents, alright? So be careful with that. Notice the order that I did this in. I got rid of the parentheses first, which is kind of what we suggested during class. Get rid of those parentheses. Notice this looks a lot better than what we started with, okay? So get rid of those parentheses. Use your exponent rules in order to simplify after that. Alright, number 7. So this one has lots of different parts. And if we look at these differently or separately, hopefully that would be a little bit helpful, okay? So let's go ahead and take a look at the numerator first. Just the numerator, that's all I'm going to look at. And we have that 8. There's nothing to do with the 8 because there's not even any other numbers. So don't worry about that 8 being there. That is not 8 to the power of 6. That's the 6th root of c to the power of 4. So please keep that in mind as you're doing these problems. And now I talked about this, we're simplifying these using exponents, which is what I'm going to do at this point, alright? I would rewrite that c as though it were 4/6, and a as though it were a negative 2/6, and b as though it were a 5/6. Now we can't simplify this exponent of b, but we can for a and c. So let's see how that turns out. We've got c to the power of 2/3, all divided by a to the power of negative 1/3, b to the 5/6. Well, that power of a is negative, so we'll reciprocate only the a. What that leaves me with is an 8 c to the 2/3, a to the 1/3, b to the 5/6. And let me double check just to see if this wants us in. It didn't really say. So technically we could leave this just as it is, but some of you may prefer to write this in radical notation. Again, I can keep it like this if I want. That's fine and done. But let's go ahead and look at what this would be like in radical notation. Okay, so if you wanted to, you'd have 8, and would have the cube root of c squared a all over the 6th root of b to the 5th. So this is up to you. I don't care which way you write it, but I will say that if you split this up, that's not completely simplified in my book, and you may miss points on that problem. So since it talked about exponents, just leave it in exponential form and be done with it. All of this stuff right here is just extra work. Alright, find the distance between a pair of points. So the first thing we've got to do is find out how far away these values are from each other. And we'll use the Pythagorean theorem for this, alright? So if we look at -2 square root of 5, and we see how far away that is from a -1 root 5, because there's that phantom 1 right there in front of that second point, the square root of 5. Well, that just means that they are 1 unit apart. So in the square root, they're 1 unit apart. We'll square that. Alright. Then we'll add the distance between the y values, which that's a 1 square root of 10. How far away is 4 square root of 10? Well, it's 3 units away, so we'll square that as well. Then we'll go ahead and take those squares. We got 1 squared is 1, 3 squared is 9. That means that's a square root of 10. That's our final answer, except what it does want from this. What we want here is not just this exact value, but also list the decimal value for that, okay? And you can type that into your calculator, which I'm going to do at this point. Square root of 10 is, looks like it's 3.162. I'm going to go ahead and round to the fourth decimal place, just like it did in the book. There's our second answer, alright? So this was a little bit different than what it was on the original answer key online. I apologize for that. I don't know what happened. Maybe I was looking at a different problem. But this is going to be the answer for this one. Alright, number 9. We need to find the midpoint of the line segment whose endpoints are given. So we just need to find halfway between these, alright? So for example, let's go and list these points, negative square root of 2, 0, and 0, -4 root 6. Ignore this decimal right here. It's not really important. Well, how far apart is -2 from 0? Well, it's -2 away. So if we wanted to cut that in half, it would be, so it's a negative square root of 2 distance away from that. So halfway between that would be just -2 over 2. That's our x value, as it turns out. Then how far away is -4 square root of 6 from 0? Well, cutting that in half would just take -4 square root of 6 and divide that by 2. Alright. The thing is we can simplify that y value, which means the x value is not going to change, a negative square root of 2 over 2. But the new y value is a 2 square root of 6, because we can take that -4, which I forgot the negative, there it is, -2 square root of 6. Now you may use the formula of this, which can be found from your notes hopefully, and that would be okay. You're just adding the x's and then the y's and dividing that value by 2. That's not going to be a big deal, okay? So I can go ahead and write that though for you, alright? So here it is. What you would do is you would take x2 plus x1 divided by 2, and then y2 plus y1 divided by 2. But I'm not so concerned about these formulas. That stuff. However you use those formulas is really up to you, okay? But I need you to understand the concept of that. If we were to look at this problem, for example, if I were to have this graphed, so -2, 0, and then -4, 6, -2, square root of 2, maybe somewhere around here, okay, negative square root of 2, and then -0, -4, square root of 6, maybe that would be somewhere down here. And so again, we're just going about halfway here. Let's say this is halfway, so it's got to be on this line, and then halfway between the zeros is right about here. The intersection there is that point. It would be right on that line. Sorry, that's not very proportional or a very good drawing, but that's it. Alright, number 10, we're going to go ahead and subtract, but before we do that, we need the radicands to be the same, and also the exponents if we pull any out. Okay, so there's a couple ways we can do this. Let's go ahead and look at the way, kind of the way we did this in class. So the first thing I'm going to do is take this first expression, with this will be subtraction between, but I'm going to split this up, and I want to find perfect squares that are factors of 75. 25 is one of those. 25 times 3 times x to the 11th. But in actuality, yes, I can go ahead and split up that x to the 11th. I just need the next lowest even number, because this is the square root times x to the 1 power. And what this allows me to do is to pull out the 25 and x to the 10th. That gives me a 5, x to the 5th. And then I have the square root of what's left over, the 3 and the x will stay in the radicand. Likewise, I'll do the same thing with this term. So we've got this 6 times the square root. One factor of 12 that's a perfect square is 4. So 4 times 3, x to the 10th times x. And this means that we'll subtract from this. I would have a 6 times 2 times x to the 5th times the square root of 3x. So I took the square root of 4, the square root of x to the 10th, and that's where the 2 and the x to the 5th came from. The next thing I'll do is multiply that 6 and 2. Everything else stays the same for now. Some of you may have already done that in your work, and that's okay. But yeah, that's going to be a 12 x to the 5th square root of 3x. So looking at these, we have an x to the 5th square root of 3x, x to the 5th square root of 3x. So we can combine the 5 and 12. And the 5 minus 12 would give us a -7. And then we've got x to the 5th square root of 3x. And this is our final answer right here. Alright, this says add, so I think that's just a typo, and I apologize about that. We're going to add these, alright? So doing this, what we need is common denominators, and then once we find common denominators, you'll see why we need that square root of 5 to be the same for both the term on the left as well as the right. Let's go and take a look at this. To find common denominators, I'm going to multiply this term on the left by 7, term on the right by 2. So I'll multiply the 8 by 2, 10 by 7. Okay, in this way, we're not changing the value of each term. We're just changing the numerators and denominators to be what we want them to be, okay? 7 times 10 to the square root of 5 would give you 70 square root of 5 over 14, plus 2 times 8 is 16 square root of 5 over 14. Okay, now Now that we have common denominators, we can make one full fraction out of this. We're going to have 70 square root of 5 plus 16 square root of 5. And since we have the same radicand or radical for both terms, what that allows us to do is to add the 70 and 16 kind of. Alright, on number 12 we're going to multiply. Same thing on number 13. So let's go ahead and get that done. Some of you may notice that this is in the form a minus b and a, well I guess it'd be a plus b, a minus b. So that is just going to be a squared minus b squared, okay, the difference of squares, which just allows us to take a quick shortcut. The a value is 2 square root of 6. Let's go and square that, then we'll subtract. That's an 8, which is the b value squared. So that would give us 4 times 6 minus 8 squared is 64. So 24 minus 64 gives us a negative 40. That's the answer. Now, just in case you didn't know that that was the difference of squares, it wouldn't matter. What you could do is just use your FOIL technique in order to solve this. So 2 square root of 6 times 2 square root of 6 would give us 4 times the square root of 6 times 6. Then 2 times the square root of 6 minus times the negative 8 would give us a negative 16 root 6. Then 8 times 2 to the square root of 6, or times square root of 6, plus 16 square root of 6. And 8 times negative 8 is negative 64. Well, all this means is that this term is going to cancel out this one. These go away. And we're left with 4 times the square root of 6 times 6 is 4 times 6 minus 64. That's 24 minus 64, just as we already have done. That's a negative 40 again. So even if you can't remember that that's the difference of squares, it's not a big deal. Just use your FOIL techniques, which is the most important part, because memorizing those rules may not be as effective for some of you. Alright, on number 13, we're just going to distribute this square root of 17. So square root of 17 times 5 is 5 square root of 17 minus square root of 17 times the square root of 17. I'll go and write this out, though some of you may know what that is already. So 5 times the square root of 17, we don't know what that is. It's irrational. Don't worry about it. Square root of 17 times the square root of 17 is just 17, and we're done. Alright, so for 14 and 15, we're going to go ahead and rationalize each denominator and then simplify if we can. So, as you guys hopefully may remember, is we're going to need the conjugate of the denominator, which in this case would be, so I'm going to put that in parentheses. We're going to multiply that by the square root of x minus 4. Alright, so this is kind of going back to that difference of squares thing. It's going to get rid of that square root for us while just squaring the 4. But if we do it to the denominator, we've got to do it to the numerator as well. Putting these in parentheses, okay? So, working this out, I'll go ahead and just do this right here. I'm going to work in the numerator, so let's give ourselves some space. Square root of x times the square root of x is x. Square root of x times negative 4 is a negative 4 square root of x. And then we'll do negative 4 times the square root of x is negative 4 square root of x. Negative 4 times negative 4 is a positive 16. We'll do the same thing in the denominator rather. Square root of x times the square root of x, x. Square root of x times negative 4 square root of x. 4 times the square root of x, positive 4 square root of x. 4 times negative 4, negative 16. Don't cancel anything out until we combine like terms, okay? Once we start factoring things out, once we have everything factored, then at that point, then we can start canceling things out. Some of you have done that in the homework. I just don't want you to make the same mistake, all right? So this negative 4 square root of x will cancel out that positive 4 square root of x. And we can combine these, which would then give us x minus 8 square root of x plus 16, all divided by x minus 16. That's it. There's nothing else we can do here. There's nothing we can cancel out. We could try to split these up. It's not going to help us out. That is done. Alright, just to rationalize the denominator, it's not a big deal. Just multiply both of these by the square root of 15. Okay, because the square root of 15 can't be factored anyways. So, that gives us 10 square root of 15, x. I guess I could put the x in front, couldn't I? I apologize. 10 x square root of 15 all over 15. Well, this is nifty now because we can simplify these, 10 and 15 to 2/3, giving us our final answer, which is 2x square root of 15 all over 3. That's it. Alright, let's go ahead and solve this one. Alright, so to do this, we're going to need to add 3 to both sides. This is going to change the equation just a little bit. Square root of 9x equals x plus 3. Now what happens is if we square both of these, that's going to take away the square root. So that's going to be a 9 plus x equals, so squaring that is actually going to give us x squared plus 6x plus 9. Now what we want to do is separate these, or combine both sides rather, so that they're on the same side. I'm going to subtract x from both sides, or 1x. And then I'll subtract 9 from both sides. What this does is it'll give us those zeros. So we've got x squared plus 5x, and the 9's cancel out there. From this point, what I'll do, sorry, I'm running out of room, I'll show the whole thing in a second, is I'm going to factor out an x from both of these terms, which gives me an x plus 5. Then I'll set both of these equal to 0. I've got x equals 0, so that's already one solution. And then I also have that x plus 5 needs to equal 0, which tells me that x is a negative 5. Alright, now before you finish this, just consider the original equation, which is up there on the top left. Square root of 9 plus x minus 3 equals 6, x rather. Let's go ahead and substitute those values just to make sure that this is going to work, alright? So, in other words, I've got the square root of 9 plus 0 minus 3 should equal 0. Is that true? Well, that would give us 3 minus 3 equals 0. 0 does equal 0. That checks off. Let's go ahead and try now with this x equals negative 5. Well, we've got the square root of 9. Let me give myself some more space. Sorry about that. I got the square root of 9 plus a negative 5 minus 3. This needs to equal negative 5. So the square root of 4 minus 3 needs to equal negative 5. That's 2 minus 3 equals negative 5. Negative 1 does not equal negative 5, so this actually ends up not being an answer at all. The only answer we have on this is x equals 0. Now the reason some of you may be asking why that happens that way is because that's a square root. Technically there should be two answers to this, but there just is not. Okay? In other words, this answer ends up being more imaginary than real. Alright, 17, this is I to the power of 50. Well, in order to figure this one out, some of you may remember this. I is just I. I squared is a negative I cubed is a negative I, and an I to the fourth is a positive 1. So this should help us to figure out what this is. Let's go ahead and look. I to the power of 50, all we're going to do is divide this by 4 and see what we get. Alright, and what that would end up being is 12 and 2/4. Okay, so we can ignore the 12 because that just puts us right back where we started at I. Okay, and then we're just going to look at the second power of this is would be like a squared there. So I don't know if that is really helpful, but I'm just looking for I squared in this case, because 48 fourths plus the 2/4, that gives us the 50 parts with the 48 and 2. Well, 48 fourths, that's 48 goes into 4 evenly, so we don't need to worry about that, okay? This pattern is going to repeat, and once we get to I to the 5th, then it's just I again, okay? So this pattern repeats, and it will repeat every 4 terms, which is why we can cancel that out. We'll just look to the second part, which in this case is -1. So the final answer to this is -1. Alright, perform the indicated operation and simplify. Write the result in the form A plus BI. Alright, that's alright. We can do that. Hopefully that should be pretty simple. Now, since right away on 18, let's go and take a closer look at this. We have a negative square root. So we know we can pull an I out of that. Square root of 27 times the square root of 10. Some of you know that we can factor out or factor that 27. Let's go and rewrite that. I times the square root of 9 times 3, because it's kind of important to look for those factors of numbers that are perfect squares, or if you're using cube roots, then cubes and so forth. So that would give me a 3i square root of 3 times the square root of 10. So that's 3i square root of 30. But we wanted this in the form A plus BI, and the A value is just 0. This is our final answer. 0 plus 3i square root of 30. Alright, let's take a look at 9. So we're going to square this. I'm going to go and write this out just so we can see what it is. And now I will use the FOIL method. 7 times 7 is 49. 7 times -5i, -35i. -5i times 7, -35i. -5 times -5i times -5i is a positive 25. But that's an I squared. I guess I'll go ahead and write that out actually. I squared. And now if we combine these parts, we can combine these two terms. We're going to have 49 minus 70i. But this is now going to be a plus 25 times a -1. So that leaves us with 49 minus 70i minus 25, and combining like terms, looks like we'd get 24 minus 70i, and this is already in the form A plus BI, and we're done. Alright, 20 is one of those tricky ones because we don't need to do anything with this first set of parentheses, but since that second one is a minus, what we're going to have to do is change these signs, and this is where a lot of people make their mistake, alright? This is now a plus I. This whole thing was negative, so we've got to take the opposite of both the 2 and that negative I. Alright? Since this is the case, all we need to do now is combine like terms. We'll take 2 minus 2, which is 0. Then we've got a negative 4i plus that's a 1i. Gives us a negative 3i. And that would be it right there for that one. Alright, so again, all we're trying to do is get this in the form of a plus bi. So what we're going to do here is to get rid of that I in the denominator. Is kind of like getting rid of the denominator itself. Let's go ahead and multiply this by a 5i, both in the numerator and the denominator. 5i. What that'll do is just make that denominator negative, okay? So distributing the 5i into the parentheses would have a 35i minus 50i squared. Okay, so that I squared is going to be important because I squared is negative 1. Likewise, in the denominator, we'll have 25i squared. And this allows us to break this up. Now, we've got 35i minus 50 times negative 1, but also divided by 25 times negative 1. So, what we end up with is a 35i minus a negative 50 all over negative 25. But since that's minus a negative 50, we're going to go ahead and add that together. That's going to give us an answer. Well, not quite an answer yet, I apologize. Just going to give ourselves some more space. Splitting this fraction up would have 35i over negative 25 plus 50 over negative 25. So this is going to split this up. We can simplify both of these fractions. That'd be a negative 7i fifths minus 2. But this is just in kind of a reversed form there. The final answer would be a negative 2 minus 7i fifths. And it doesn't matter. You can put the I on the side if you want. It's not going to matter. So A plus BI. Alright, now some of you guys know that I suppose that was kind of a long route to do this. What we can do is split this up kind of thing, I guess. Really, we didn't need to multiply by the 5, but all we need to do is multiply by the I. So if we multiply both of these by I, then our denominator no longer has an I. That's great. So this would be 7i minus 10 times, I'm just going to skip that step, 10 times negative 1 over 5 times negative 1. So that would give us 7i plus 10 over, now it's a negative 5. So splitting that up would get a 7i over negative 5 plus 10 over negative 5. And that's just going to equal, because we want this in the form A plus BI. So that's not a plus, so it's negative A minus, what am I doing? Negative 2 minus 7 fifths I. There we go. Now, I believe I had that written wrong on the practice test. I apologize again. I try to do my best to type those in, so I hope this is helpful. Alright, 22, we just need to find the hypotenuse of a triangle with legs, lengths 9 foot and 11 root 5 foot. So let's go ahead and draw a picture of this. Some of you may find that helpful. I don't know. Alright. But this is a right triangle. Since we're talking about a hypotenuse, that's the value that we want. And we have lengths of 9 feet and 11 square root of 5 feet. Okay, don't forget to label these, please. And in order to solve this, this x value is going to equal the square root of squares the sum of the squares of the legs. So we've got 9 squared plus, that'd be 11 square root of 5 squared. And finishing this off, we get the square root of 81 plus 121 times 5. So that's the square root of 81 plus 605, which is the square root of 686. I don't think that's a perfect square, but I can go ahead and check that. Square root of 686, I'm just using my calculator here. It's not, but I do know, and I can tell from that we could take this. This would end up being the square root. Ourselves some space here. That's the square root, as it ends up being to 7 squared times 14. Or in other words, 49 times 14. You can check that. That'd be 7 times the square root of 14 in feet. Alright, and if you wanted to go the extra mile for some reason, taking a huge risk, then you may write this as a decimal, 26.1916 feet. I just rounded to the nearest fourth, but again, I highly recommend that you make your answer just the exact value, which is 7 times the square root of 14 feet. And that concludes the practice test. I hope you've enjoyed it and that you have found it helpful. Yeah, so go ahead and practice all you want. You have spring break and a little bit of the following week to study. Study hard and be prepared for this test. And I hope it helps out. All right, you guys have a good one.